What if time could start ticking inside a system with no outside clock at all? That is one of my favorite questions of the week. And welcome. This is episode 1, our Science of the Week for July 16th. I'm Grace.
And I'm Daniel. We've got a full bench, a deep space probe waking up beyond the giants, a new primate with a striking look, a sky show with planets and meteors, the sun nudged into eruption, a faint pulsar measured by a giant radio dish, and yes, that lab where a kind of time seemed to emerge on its own.
It's a week that moves from forest canopies to quantum chillers to the outer reaches of the solar system, which is another way of saying, put the kettle on, we're going wide.
I'll keep score on what's solid, what's preliminary, and where the caveats live. And as ever, no hype, just the science.
Let's start with life on Earth, a face we've never formally met before. Scientists working in the Democratic Republic of Congo identified a new Colobus monkey species in Lomami National Park. It was reported by the BBC, and the team is from Florida Atlantic University, led by Junior Mboko and Kate Detweiler. The new species has a memorable calling card: orange lips.
Taxonomically, that's a clear claim, identified as a new species and given a formal name. The report credits the leadership to Junior Mboko and Kate Detweiler and places the discovery in Lomami National Park. What we do not have in this roundup are the technical criteria, for example, the detailed morphology, genetics, or the sample sizes. So I'll refrain from extrapolating beyond identified and described.
Still, the idea that in 2026 we are adding a primate to the catalog, that's a reminder that the map of life is not finished. The orange lips detail is vivid because it's a simple human way to picture difference, but it stands for deeper distinctiveness.
Right. The significance in plain terms? Formal recognition matters for conservation and for how we study primate evolution. But without the underlying data set here, we can't speak to population status or to any behavioral or ecological traits. We can say the identification is reported and who led it.
And it's in a protected park, which at least gives it a stage on which to be seen and studied. I love that.
Also worth noting, attributing it to specific researchers is valuable. It means there's an anchor for readers to look up the work as details become public.
If you needed a moment of wonder this week, imagine stepping into a forest and realizing the face in the canopy isn't in the books yet.
And then, imagine filing the paperwork. Science is a romance that ends with a lot of forms.
Quick stop in medicine and health. This week's roundup doesn't include a clinical trial or a treatment study, and that's okay.
It is. Not every week yields vetted, practice-changing medical results, and absence is better than overreach. The best habit for health stories is patience. Wait for sample sizes, controls, outcomes. If we don't have them, we don't make them up.
Exactly. We'd rather leave a quiet spot than fill it with noise. Okay, let's step outside and look up. Skywatchers, mark your calendars lightly. According to KCCI, astronomers say the upcoming month is set to feature clear views of Mars, Saturn, and Venus. A new moon will give you a nicely dark sky, perfect for stargazing.
They also note the southern Delta Aquarids meteor shower is expected to begin in the middle of the month, and that a full buck moon will brighten the sky later. The phrasing there, expected and upcoming month, tells you we're in preview mode, not post hoc observation.
Which is a gift. It's permission to plan a night outside. If you've never seen Saturn through even a small telescope, this is your nudge. And Venus? Always a showstopper, near dusk or dawn.
Methodologically, this is celestial mechanics and seasonal observing. The confidence is good for visibility windows. The exact experience still depends on weather and local light pollution.
Practical tip? That new moon period is your friend for fainter objects. Then the buck moon brings the big lantern in the sky. Less ideal for dim things, great for a mood walk.
And for context, previews like this are conservative. If anything, the main pitfall is clouds, not the planets failing to show up.
Rain checks are part of the hobby. When the clouds clear, it feels like the universe rescheduled just for you. Speaking of the outer dark, NASA's New Horizons spacecraft stretched, yawned, and got back to work. CNN reported that it emerged from its longest hibernation and began transmitting scientific data from the Kuiper Belt. It's about 5.9 billion miles from Earth.
That's deep. The report also says it had been placed in hibernation in early August. The firm facts we have: the craft is awake, sending science data, and it's in the Kuiper Belt at that vast distance.
I love that a probe we flung out years ago is quietly phoning home from the cold, still doing science. There's a steadiness to that.
It also illustrates a mission cadence: conserve energy and instruments with hibernation, then wake for planned campaigns. And for anyone tempted to read more into the state of the instruments or target objects, we don't have those details here, so we'll stick to data transmission resumed.
At nearly 6 billion miles, home becomes a generous concept. The fact that a whisper can cross that gulf is a small miracle of patience and radio.
A very carefully engineered miracle. And a reminder that exploration is often a series of updates rather than a single headline.
I'll take those updates. Each one pushes the frontier a step farther from lonely. From one radio story to another, the 500-meter Aperture Spherical Telescope, FAST, detected faint radio pulsations from a pulsar with the glamorous name PSR J2238 plus 5903. ScienceCast reported it captured micro-Jansky-level pulses in a 3,000-second observation.
The notable bit is that those pulses provided a distance estimate, a dispersion-measured distance, for a nearby very high-energy source designated 1LHAASO J2238 plus 5900. That's an example of how one measurement can illuminate another target indirectly.
Translation to everyday terms: by measuring a very faint, periodic radio heartbeat from a known kind of object, you get a handle on how far away something in the same patch of sky might be.
Exactly. And to keep it rigorous, what we have are faint radio pulsations, the length of the observing run, and that a distance estimate resulted. No error bars or exact distance value were given here, so we won't speculate. Also, the connection is about proximity in the sky and inferred distance, not proof of a physical relation beyond what's stated.
It's a nice reminder that astronomy is often detective work. Sometimes you don't measure the thing directly. You triangulate using the thing that's willing to talk to you.
And if you're impressed by micro-Jansky, you should be. That's very faint. It speaks to the sensitivity of FAST and to careful signal processing.
Big ear, quiet voice, useful whisper. I like that story. Let's stay in our stars neighborhood. Researchers observed a sequence of coronal jets that disturbed a solar filament, setting it swaying more and more until it erupted rapidly. ScienceCast reported that each jet imparted momentum to the filament, amplifying its motion, and numerical simulations reproduced the process.
This is a clean example of cause and effect in solar dynamics. The observed jets, quick, narrow outflows from the sun's atmosphere, nudge a filament, which is a long ribbon of cooler, denser material suspended by magnetic fields. Each nudge adds to the oscillation until you hit an eruption.
I love the image of a cosmic swing set. Push, 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 and then whoosh. And the simulations matching the observations are the kind of check that makes me sit up straighter.
With the standard caution. Simulations that reproduce a sequence lend credibility to the mechanism, but they're not predictions of every event. The result here is observed disturbance leads to growing oscillation and eruption. Simulations can model that. We don't have statistics on how often this happens, or how general the model is.
Still, that mechanistic clarity matters for space weather. Understanding how an eruption gets primed is a step toward anticipating when the sun is in a touchier mood.
Right. The scientific value is in the chain of momentum transfer and the threshold behavior that follows. It's a satisfying piece of the solar puzzle.
And a reminder that our star is not a static ball. It's restless, and we are learning its rhythms one shove at a time. Okay, Now to the philosophical candy with a lab wrapper. Physicists at the University of Birmingham, led by Giovanni Barantini, created an isolated cloud of ultra-cold atoms, a miniature analog of the universe, and it exhibited a self-generated flow of time. According to Yahoo, the experiment showed that an internal entropic clock can arise within a closed quantum system.
This is genuinely intriguing. Let's mark the lines clearly. The experiment is in the lab with an isolated ultra-cold atomic cloud. It acts as an analog, meaning it mimics some features of a target system. And within that system, the researchers identified behavior that functions like an internal clock tied to entropy.
In approachable language, you build a tiny sealed world, chill it to near standstill, and then watch as a sense of before and after shows up from the inside.
And here come the caveats that keep the wonder honest. First, this is a demonstration within a specific quantum setup. It is not a proof that time in our universe arises the same way. Second, the term entropic clock tells you the mechanism is about increasing disorder as a way to mark progression within that system. Third, we don't have here the experimental details, uncertainties, or comparative runs, so we treat the claim as preliminary in scope, evidence that such a clock can emerge in that closed system.
Still, self-generated flow of time is a phrase that makes the hair on my arm stand up. It hints at time being something you can get, not just something you have.
It's an invitation to think more carefully about what we mean by time operationally, how we measure it, and from where those measures arise. Analogs like this are valuable because they let you experiment on concepts that are otherwise abstract or cosmological.
And because they're small enough to poke, reset, and run again. That cycle is half the magic.
Agreed. As more data appear, the next questions would be about robustness. Does the clock persist under different initial conditions? And how does measurement affect it? But for now, we stick to what's reported: emergence inside a closed quantum system.
Big thoughts from a very cold cloud. Excellent. Let's zoom out and stitch the week together. A new face in a Congolese forest, a spacecraft waking in the Kuiper Belt, a faint pulsar whisper refining a distance, the sun's nudge to eruption chain, and a lab world that finds its own TikTok. What did we learn about how the world works?
One through line is that careful observation and modest claims go a long way. The monkey story is a formal identification, not a sweeping ecological pronouncement, and yet it matters. The New Horizons update is simple: awake, sending data, location stated. That's substantial in its own right.
And the sky preview is basically an invitation to be present at the right moments. New moon darkness, meteor shower beginning mid-month, bright full moon later, and those planets lining up for easy viewing. It's science as a calendar you can live inside.
The solar and pulsar pieces show how indirect inferences can be sturdy. Momentum added jet by jet until eruption, observed and then simulated. A faint pulse yielding a distance estimate that informs our sense of a nearby high-energy source.
And then the quantum story asks whether time might sometimes be something systems make for themselves. Even if it's just in that lab world, it's a human act to poke reality and ask it to show you a clock.
Another thread is humility. We avoided adding numbers not given. No population counts for the monkey, no exact distance for the TV source, no exaggerated claims for the quantum clock. That's by design.
Science is a mosaic. Some tiles are bright and finished, some are outlines, some are placeholders that say, come back later. This week brought a little of each.
And sometimes the best thing you can do for understanding is go outside and look up, then come back in and read the data carefully.
Or listen to it, whether it's a radio pulse from a distant star or a tiny probe whispering from the fringe of our system. That's our calm tour for this week. If you want the stories we talked about and more checked, unhurried news, head to faxlane.com or find us in the apps, App Store and Google Play.
Thanks for spending time with us. We'll be back with another weekly roundup. Until then, keep your curiosity on a slow simmer. It tastes better that way.
I'm Grace.
I'm Daniel.
Take care out there. Enjoy a night under a dark new moon if you can. And we'll see you next week.
Stay curious, and goodbye for now.